vertical circular motion. Already we have studied about circular motion, but that circular motion is horizontal circular motion. Today we are going to see the vertical circular motion. In that, the first thing, that is mass tied to a string. Mass tied to a string. Suppose you consider mass m is tied to the string and rotated in vertical circle. Suppose this is the vertical circle, this is the lowest point, suppose this is the center, this is highest point, and these two are middle points. Suppose here this is the string, and here we consider we tie a mass m to that one end of string. Suppose we consider this O be the center of this circle. Now suppose this mass m moves in an anti-clockwise sense like this. It starts from, suppose L, comes to M, comes to H, again M, and again L. In this way the vertical circle completes. Suppose this mg be the mass weight of that vehicle which acts in downward direction, and suppose u, we consider u be the initial velocity at this point, lowest point. Now whenever this mass m moves like this from L to M, H up to this, then what happens? Gravity opposes the motion. Gravity opposes the motion, so its velocity goes on decreasing. Here we consider minimum velocity. And whenever particle moves from H, M, L, then gravity helps the motion, and therefore its velocity goes on increasing. That means at point L there is maximum velocity, and at point H there is minimum velocity. Suppose u be the velocity at point L. Now particle moves from point L to any point P. Suppose this point is P, and suppose v be the velocity of the particle at point P. Now suppose this angle is theta. Now here we consider this weight is mg at this point in the downward direction, and suppose this angle is theta. Again this angle is theta. Then mg can be resolved into two components, that is means mg cos theta, this is the component of mg at point P along radius, and we consider here this component by black ink. This component is, we write here mg sin theta, which is in a tangential direction. Now here suppose this height, we consider this height is h from point L, and therefore this much distance, we consider this much distance is r minus h, because this radius is r. R is the radius of the, or length of the string, therefore r is the radius of the circle. Now we consider here we have to obtain velocity of the particle at any point. Suppose v be the velocity at this point, then here we consider at point P we can write half mv square, this is the kinetic energy, plus mgh, this is the total energy, potential energy, and from law of conservation of energy we can write here half mv square plus mgh is equal to half mu square, means initial kinetic energy. This statement is from the law of conservation of energy, and therefore we write here v square plus 2gh, m get cancelled totally, we multiply by 2, therefore v square plus 2gh is equal to, we write here u square. Now here we can write therefore v is equal to square root of u square minus 2gh. Now we have to obtain the tension in the string. Tension in the string. Tension in the string. Now at point P, we write T. T means tension in the string in inward direction, and component of mg cos theta, outward direction. Also centrifugal force is in outward direction. Therefore we write here T minus mg cos theta is equal to centrifugal force mv square upon r, and therefore T is equal to, we write here, mv square upon r plus mg cos theta. T equal to mv square upon r plus mg cos theta, or we write here T is equal to mv square upon r plus mg into bracket, we write here r minus h upon r from this triangle, this triangle. Suppose OP, I will give one to this point name, suppose B. OPB. From triangle OPB, cos theta is equal to r minus h upon r, and we put the value here. Therefore, T is equal to mv square upon r plus mg into r minus h upon r. Or, suppose I will write here, or T is equal to m upon r, and value of this v square, we write here from this v equal to root u square minus 2gh, and square, we remove the square root, v square is equal to u square minus 2gh. I write here u square minus 2gh m upon r into bracket u square minus 2gh plus mg into bracket r minus h upon r, or T is equal to, I will take here m upon r to be outside from whole quantity, and therefore I will write here v square minus 2gh plus gr minus gh, which is equal to m upon r into bracket v square minus 3gh plus gr, like this. Now first thing we consider here, at lowest point h is equal to 0, and therefore tension in the string is equal to m upon r into bracket v square plus gr, since h is equal to 0. Second one, at highest point eh is equal to 2r. Here this r plus this r means h is equal to 2r. This is lowest point. Now th is equal to m upon r into bracket v square minus 3g into 2r plus gr, and which is equal to m upon r into bracket v square. See here 3g into 2r means 6gr, and this plus gr minus 6gr plus gr, we write here only minus 5gr, and this is the tension at highest point. Now we will obtain difference of tensions between lowest and highest point. Therefore TL minus TH is equal to, subtract these two, TL minus TH. M upon R is common. Therefore I write here V square plus GR minus this. I write like this. Minus V square and minus this. Minus becomes plus. I will write 5GR. This V square gets cancelled, and therefore TL minus TH is equal to M upon R into 6GR, and again this get cancelled, which is equal to 6 mg, which is equal to 6 into weight of body. That means tension between these two, TL minus TH, this difference is 6 into weight of the body. Now we will obtain minimum velocity at highest point. Minimum velocity at highest point. Minimum velocity at highest point. Whenever particle moves from LMH, then to reach at the highest point, this tension in the string, suppose this is the string, tension in the string must be greater than or equal to 0. That means at highest point, TH greater than or equal to 0. Or we can write here or. Where is the value of TH? TH is, we will consider TH is here. That means M upon R into bracket V square minus 5GR greater than or equal to 0. That means V square greater than or equal to 5GR, or we write here at highest point V square greater than or equal to 5GR. Therefore V square equal to, we write here V square equal to U square. V square equal to, see here, V square equal to, I will write here V square equal to, from this equation, V square equal to U square minus 2G into H means 2R. V square is equal to U square minus 4GR. TH is equal to, we will write here V square equal to U square minus 5GR. And VH square equal to, I will write here VH square equal to 5GR minus 4GR. And therefore VH is equal to root GR. Now at middle point, I will write here V square is equal to U square minus 2GR, and V square is equal to 5GR minus 2GR, and therefore we get here V square is equal to 3GR, and therefore V is equal to root 3GR at middle point. This is for middle point. And here we can get here for highest point U square M upon R. V middle point we get here V is equal to root 3GR. Now this is all about velocities at different points. This is middle point, this is highest point, and this is we consider lowest point. For lowest point, VL is equal to root 5GR. Now we can write here energies at different positions. Suppose I will sketch this for energies. Figure is same for energies. Energy at different positions. Energy at different positions. At lowest point, at point L, velocity is equal to root 5GR. Therefore K is equal to half mv square is equal to half as it is m as it is, and v square we write here square root of 5GR, which is equal to 5 by 2 mgr. This is the total energy at lowest point. P is 0. Pe is 0. This is Ke, and therefore T is equal to Ke plus Pe is equal to 5 by 2 mgr. Now at middle point, V is equal to root 3gr, and therefore Ke is equal to, I will write half mv square. I will write direct step 3 by 2 mgr, and P is equal to mgh, means mgr. Now total energy, therefore T is equal to Ke plus P, therefore 3 by 2 mgr plus mgr means 5 by 2 mgr. This is for middle point. Now I will write for point H at highest point here. V is equal to root gr, and therefore Ke is equal to half mv square. I will write directly half mgr. P is equal to mgh, means mg into 2r, means I will write 2 mgr. Now total energy T equal to Ke plus P, means half mgr plus 2 mgr, means I will write directly 5 by 2 mgr. That means if you observe the total energy at different positions, at point L total energy is 5 by 2 mgr. See here, 5 by 2 mgr, this one. At lowest point, at middle point, again 5 by 2 mgr, and at highest point, again 5 by 2 mgr. That means law of conservation of energy is verified. Now second example here, vertical circular motion. I will consider that mass tied to a rod. Whenever mass is tied to a rod, then one condition or one difference between mass tied to string and mass tied to rod, that tension, in case of rod, tension is not necessary, but in case of string, tension must be necessary. Now here we get here, therefore if we calculate all these things, suppose we consider this is the vertical circular motion of the rod. Suppose O be the center. Suppose this is the rod and this is the mass. Suppose this is the lowest point and this is the highest point. This one is the middle point. All this. Then difference between these two, that is mass tied to the string and rod, that this tension in case of string is not here. Tension doesn't play any role. Then maximum velocity maximum at lowest point, here we get here 4 rg, which is equal to 2 root rg, and upper low we get here, that is a v minimum at horizontal position. Here we get root rg, root 2 rg, and upper position we get only rg, or minimum velocity, zero velocity may be possible there instead of this rg. And here tension or difference between the tensions, here in case of rod it is again 6 mg. This is all about vertical circular motion. We have to study one thing again, third, that is sphere of death. We usually see, suppose this is the convex bridge, and suppose on this convex bridge, suppose we get here, suppose this C be the center, R is the radius of this convex surface, and suppose vehicle is here. Then N be the normal reaction, and mg be the weight which is in downward direction. And we get here vehicle is traveling along this convex bridge like this. Now here weight mg acts in downward direction, normal reaction in upward direction. If v is the speed of that vehicle, then mg weight minus n means normal reaction is equal to, we write here, mv square upon r. That means centrifugal force. Now here we get and as speed increases, n goes on decreasing. For maintaining contact, n must be equal to 0. This imposes an upper limit, and this velocity in this case is v equal to rg. As like vertical circular motion at top, in case of vertical circular motion, here v is equal to root rg. In case of string or rod, in case of rod it may be 0, but in case of string there is v equal to root rg. This is the velocity, upper limit of the speed. And if the speed increases beyond this limit, then it is dangerous to, in case of that vehicle, there is a accident. This is all about vertical circular motion. I hope all you are understand all these. Thank you.